Hi students, this is Mr. Yang. Today we are going to talk about 5.9c, where we will learn even more about trig identities and how to do proofs with them. Today's lesson will be a bit more complicated since we're also going to have factoring and distribution with these trig identities. So please try to follow along. Prior knowledge, let's review some factoring real quick. The first two are actually about difference of perfect squares. That's what we have learned in Unit 1. Let's have a look. First one, a squared minus b squared is going to be factored as a plus b times a minus b. b, 1 is a perfect square, 25 is a perfect square, so this is going to be factored as 1 plus 5x and times 1 minus 5x. And just a quick reminder, when they're both perfect squares, whatever their square roots are, we just put them inside the parentheses, 1 plus sign and 1 minus sign. That's how difference of perfect squares work. See, that one is just to remind you, whenever we have a square, we are going to need to write it twice and do our distribution. That's going to give us x squared plus xy, which is plus 2xy, and then plus y squared. That's C. Now let's quickly recap Pythagorean identity that we have learned, which is sine squared plus cosine squared equals 1. We've also learned how to rewrite it, but today with the factoring, we're going to rewrite it even more. Sine theta squared is 1 minus cosine theta squared. And since that is a perfect square, that 1 is a perfect square, that cosine theta squared is also a perfect square, we can use the difference of perfect squares to write it as 1 plus cosine times 1 minus cosine. Then of course we can do the same thing for cosine squared. Cosine squared is 1 minus sine squared, that is going to be 1 plus sine times 1 minus sine. Now let's get to the examples. Example 1. Clearly the left-hand side is a bit more complicated. We are going to start on the left-hand side. Cosine squared, we can rewrite it as, also because if you look at the bottom, we have sine. The right side also have sine. So of course, we're going to rewrite the cosine squared as sine squared. So that's going to be 1 minus sine squared on the bottom. on the top. The bottom is going to be 1 minus sine theta. And now for 1 minus sine theta squared, as what we have just talked about, we can actually take it apart using factoring. That's going to become 1 plus sine times 1 minus sine, with a 1 minus sine on the bottom. Something to be clear, you can't just choose to cancel the sign, because we have to cancel with multiplication. But this is subtraction, so you can't just cancel with the sign. It's the 1 minus sine that's canceled with the 1 minus sine on the top. So we are left with a 1 plus sine theta. That is what we have on the right-hand side. We have just proved number 1. Next, example 2. Clearly, we're going to start on the left-hand side because that's more complicated. But then there's kind of not much we can do. So we might want to just try to rewrite using sine and cosine. Sine theta. Tangent is going to be sine theta over cosine theta. The bottom, 1 plus secant is 1 over cosine. If you feel like, well, I already know we're going to do the fractions, so you might want to just put everything over 1 to remind you, hey, we need a common denominator. And in this case, we have denominator 1 cosine, 1 and cosine, so the common denominator is going to be a cosine. So we're going to multiply everything by a cosine. I suggest you multiply them separately so that you don't forget it's actually multiplying on the whole top and the whole bottom. So that cosine cancels, we are going to be left with a cosine theta times sine theta plus a sine theta on the top. On the bottom, we will have a cosine theta plus a 1. Now, you may have noticed, on the right-hand side, we don't have any cosine. So clearly the cosines are gone. But it's not just by crossing them out, because we have these plus signs, so we can't just randomly cancel them out. Instead, on the top, we actually have the sine theta and another sine theta. So we can actually factor out the sine theta. We're going to be left with a cosine theta plus a 1. And the bottom is cosine theta plus a 1. So again, this is just like we have, say, a yx plus an x. So we can take out the x and be left with a y plus 1. It's the same idea. It is just factoring. The two terms have the same thing that we can factor out. Now we can actually cancel the cosine theta plus 1 on the top and the bottom. We are going to be left with just a sine theta. that is our right-hand side. Check mark. That's example 2. Next, example 3. Both sides are fractions, but the left-hand side clearly have this sign cubed. That looks a bit more complicated. But the right side is a cosecant over a 1 minus cosine. Here's the thing. Yes, typically we would start on the left-hand side, which is fine. You can totally do that. But this is a bit special. With this 1 minus cosine on the bottom, clearly we cannot just work with 1 minus cosine. If we want to use the identities, we're going to have to do 1 minus cosine squared. And that's where we would know we are going to need another piece to actually make this 1 minus cosine squared. So in this question, I'm actually going to start on the right-hand side. And I'm going to copy it down again. So 1 minus cosine. I can also show how to actually use the left-hand side. It's kind of a similar idea. But in order for the 1 minus cosine theta to become 1 minus cosine theta squared, I need to do something. I need to give it an extra piece, which is 1 plus cosine theta. So I'm going to multiply the whole thing by a 1 plus cosine theta on the top and on the bottom, because this whole thing is basically a 1, so I didn't change what the question is. I just kind of forced my way to use the Pythagorean identity. Now in this case, I would have a 1 minus cosine times a 1 plus cosine on the bottom, which is 1 minus cosine squared. The top is cosecant times 1 plus cosine. Here's the reason why I'm not distributing right now. Because I'm noticing on my left-hand side, I do have 1 plus cosine. So that means I need that in my final answer. So I'm going to keep it that way for now. Now the bottom, 1 minus cosine squared is going to become sine squared. And top is going to be cosecant times 1 plus cosine theta. And we can clearly rewrite the cosecant to be 1 over sine. We still have this 1 plus cosine theta on the top, and the bottom is going to be a sine theta squared. Now it's time to try to get rid of the sine on the top. So I'm going to multiply the top by a sine and multiply the bottom by a sine. I'm just trying to get rid of the common denominator because the bottom is basically sine squared over 1. So that is gone. I'm going to be left with 1 plus cosine theta over the sine squared times another sine is going to be sine theta cubed. And that is my right-hand side. So I just proved it. For this question, if you would like to start on the left-hand side, that's totally fine as well. The only thing is you may have to notice that sine cubed is basically sine squared times another sine. So you are going to need to rewrite this sine theta squared as 1 minus cosine squared. So that works as well. If I have space, I may come back to example 3 to show you how to start with the left-hand side. Next, example 4. So this one, there's not much we can do to begin with. So I'm going to just start by rewriting everything using sine and cosine. Since I may need space for example 3, I'm going to write on the top right here. Start on the left-hand side. Secant is 1 over cosine, and cosine on the bottom. I can write it as a cosine over 1. The tangent is sine over cosine, and cotangent is cosine over sine. Now, here's the more complicated stuff for this one. For the first part, I can choose to just multiply everything by a cosine. I'm going to get so that is canceling. If that is canceled, I have a 1 over cosine squared. For the second part, you can choose to multiply by a cosine, but you also need to multiply by another sine. That's where things get a bit more complicated. So I can also choose to do that by multiplying the reciprocal. So I'm going to multiply and then flip the bottom. So the bottom becomes sine over cosine. Now this whole thing becomes 1 over cosine squared minus, that is a sine squared over a cosine squared. Ooh, we have common denominator. So I can just put them together, cosine squared on the bottom, and the top is 1 minus sine squared. Clearly, 1 minus sine squared is just cosine squared. So the whole thing becomes cosine squared over cosine squared, which is a 1, and that is my right-hand side. We have just proved that. So now let me go back to example 3 and kind of show you how to work from the left-hand side. If I start from the left-hand side, I'm going to rewrite the sine theta cubed as sine squared times sine. So it's going to be 1 plus cosine on the top. And the bottom, the sine squared part becomes 1 minus cosine squared. But we are still left with another sine. Now I can take apart the 1 minus cosine squared. That's going to become 1 plus cosine and a 1 minus cosine times another sine. The top is a 1 plus cosine. Since everything is being multiplied on the bottom, I can cancel the 1 plus cosine part. So the whole thing just becomes 1 over 1 minus cosine theta times the sine theta. And clearly, I can rewrite that 1 over sine. So this whole thing now becomes 1 over 1 minus cosine times a 1 over sine. And clearly, I can rewrite the 1 over sine as cosecant. So the whole thing becomes that, which is my right-hand side. So I can also prove it that way. Again, this is if we start on the left-hand side. That still works. Now let's move on. Example 5. This example requires you to notice that the left-hand side, the fourth powers, they are still both perfect squares. So I'm going to start on the left-hand side and take it apart by factoring the difference of perfect squares. That becomes cosecant squared minus cotangent squared times cosecant squared plus cotangent squared. And if you haven't noticed, this is exactly what the right-hand side is. So that means I'm trying to prove this part being a 1. So basically, when you try to prove these, always kind of keep in mind what you are trying to get to so that you can kind of manipulate towards that. Now, I'm going to keep the second part because clearly that is the right-hand side. I just need to make sure the first part becomes 1. I'm going to start by rewriting cosecant as 1 over sine and rewriting cotangent as cosine over sine. Ooh, they have the same denominator. So common denominator, put the sine there, and the top is 1 minus cosine squared. Of course, I'm going to need to keep the second part, cosecant plus cotangent. The first part, this becomes sine squared. So the whole thing is just sine squared over sine squared, which is a 1 times cosecant squared plus cotangent squared, which is just cosecant squared plus cotangent squared, and that is my right-hand side. And that is done for example 5. Next, example 6. This one, we are going to rewrite everything using sine and cosine. So the left-hand side is going to be 1 over cosine squared. The bottom is going to be 1 over cosine squared minus 1. Here's the thing. For these secant and tangent and cotangent stuff, in the future, you are going to learn a bit more about Pythagorean identities. There are easier ways to work with them. But for this year, we are just going to use these ones that we already have learned to work with them. So now I need to get rid of the denominator by multiplying everything by a cosine theta squared. That is gone. That is gone. So I will have 1 on the top and a 1 minus cosine theta squared on the bottom. So the bottom just becomes sine theta squared. The whole thing is 1 over sine theta squared, which is cosecant theta squared. That is my right-hand side. That is example 6. Next, example 7. Let's start with the left-hand side. Secant is 1 over cosine, and we have another sine. The bottom, tangent is sine over cosine, and cotangent is cosine over sine. The more you work with these, the more you will actually remember tangent plus cotangent is just 1 over sine times cosine. But for now, we are going to still use a common denominator way. The denominator is a cosine and a sine. So I'm going to need a sine and cosine to get rid of them. A sine and cosine. And the top, same thing, a sine and a cosine. Cosine is gone. Here, cosine is gone. Here, sine is gone. So we will have, on the top, sine squared. On the bottom, we have a sine squared plus a cosine squared, which is a 1 on the bottom. So the whole thing is just sine squared, which is my right-hand side, And we're done with number 7. Number 8. This is a slightly more complicated example, but the idea doesn't change. Remember, we are working with fractions, so we are going to need common denominators. And the denominator, one of them is a 1 minus sine theta, the other is a cosine theta. These things, they will almost never share anything because of the plus and minus, because we have a 1 minus sign. So the whole thing is just going to be 1 minus sine times cosine. That is our common denominator. In order for the first fraction to become the common denominator, I need to multiply the top and the bottom by a cosine theta. So my top is cosine theta squared. In order for the second fraction to become the common denominator, I need to multiply the top and the bottom by 1 minus sine theta. So the second part just becomes 1 minus sine theta, the whole thing squared. Now let's continue. The bottom does not change, 1 minus sine theta times cosine theta. The top is a cosine theta squared. Here's something for you to remember. Can't just square the terms inside. For this, you have to write it twice. 1 minus sine theta times 1 minus sine theta. Then do your distribution, that's going to become a 1 minus a sine minus another sine, that's 1 minus 2 sine theta. Then of course at the end we have the plus sine theta squared. So that is my second part. Plus 1 minus 2 sine theta plus a sine theta squared. That is what a parenthesis squared is going to become. Next, you may notice we have a cosine square and a sine square. So the top now becomes 2 minus 2 sine theta, because these two just become a 1. So it's got to be a 1 plus a 1, which is a 2. The bottom is a 1 minus sine times cosine. You look at the right-hand side, it's a secant. That's related to cosine. So there's nothing related to the sine. That means all of these signs will eventually be gone. So now something that you would need to notice, there's a 2, there's another 2. That means for these two terms, we can factor out a 2. Factor out a 2, we have 1 minus sine theta. And the bottom is going to be a 1 minus sine theta times a cosine theta. Of course, because of multiplication, the 1 minus sine theta, they would cancel. So we are left with 2 over cosine theta. Anything over cosine, the reciprocal rule tells us that's basically secant. So we are left with 2 secant theta. And that is my right-hand side. We are done with example 8. So this lesson has some more complicated examples, but the basic idea is you got to know how to work with the fractions. So you have common denominators, or we can rewrite everything into sine and cosine and then work with the fraction that way. Either way, that's everything for 5.9c. Thank you.